Alright guys, we're going to look at solving rational equations. Our first one here, we have x over x plus 2 plus x is equal to 5x plus 8 over x plus 2. First thing we want to do is find our restrictions. Remember, when we're working with fractions, we can't have 0 in the denominator. Therefore, our one restriction is that x cannot be a negative 2. And that's because if I replace x with a negative 2, you'll notice down in our denominator here that negative 2 plus 2 would give us a 0. And again, we can't have that in the denominator. Same thing over here. If I replace x with a negative 2, negative 2 plus 2 gives us a 0. And again, we can't have 0 in the denominator. Alright, so that's our one restriction. Now what we're going to do is start solving the equation. And in order to solve that equation, we're going to need to find the least common denominator. And in this case, that least common denominator should be pretty obvious, and that's going to be the x plus 2. Now that I know the least common denominator, what I'm going to do is take both sides of the equation, and we're going to multiply by that least common denominator. So we're going to multiply by x plus 2. So if I start over here on the left side, you'll notice that the x plus 2 with the other x plus 2 are going to cancel out, leaving me with an x. Now what I'm going to do is multiply x plus 2 times this x here. So that x plus 2 times that x, if I use a little distributive property, that leads me to x squared plus 2x equals. Now I'm on the right hand side of the equation. Notice again how the x plus 2 cancels each other out. And I'm left with 5x plus 8. So I've got this equation here, x plus x squared plus 2x is equal to 5x plus 8. You'll notice that what we're working with here is a quadratic. And we know it's a quadratic because of the x squared. And I've got a couple of different methods I can use to solve a quadratic. But regardless of what method I use, I'm going to go ahead and get this thing equal to 0 first. So I'm going to go ahead and come over here and combine some like terms. The x plus the 2x would give me a 3x. Now I'm going to move everything that's on the right of the equation to the left. So I'm going to start by subtracting the 5x. 3x minus 5x would give me a negative 2x. Subtract the 8. And I now have x squared minus 2x minus 8. So here's the quadratic I'm trying to solve. And again, got a couple of different methods. If I had a graphing calculator, could use the graphing calculator, graph it, find my zeros or my x-intercepts. But in this case, I think it should be fairly easy to factor this, so that's what I'm going to do here, factor. We know that x times x will give us the x squared. What I need are factors of a negative 8 that are also going to add up to a negative 2. In this case, those factors are negative 4 and positive 2. If I multiply negative 4 times positive 2, I get a negative 8. And if I add the negative 4 and 2, I get a negative 2. So here's my factors. Now what I'm going to do is take each one of these factors, set it equal to 0, and solve for x. So the first one over here, if I solve this for x, I get a 4. And if I solve this one over here, I get a negative 2. So my two solutions are 4 and negative 2. However, I do run into a small problem. Earlier we said we did have a restriction, and that restriction was that x could not be equal to a negative 2. Therefore, I cannot include this as a solution. It's what we call an extraneous solution. Therefore, the only solution to this equation is this right here, x equals 4. So the solution to number 1 here is x equals to 4. Right, example number 2, we've got x over x minus 3 plus 1/3 is equal to 1. First thing we need to do is start with our restriction. Remember again, can't have 0 in the denominator. And the restriction in this case is going to be x cannot equal to a 3. And that's because if I replace x with a 3, 3 minus 3 would result in a 0. And I can't have 0 in the denominator. So, 3. 3 is our restriction. Now I need to find the least common denominator. Least common denominator. I've got x minus 3 as one of my denominators. I've got 3 as my other denominator. So my least common denominator is both of these multiplied by each other. So I'm going to use 3 times x minus 3 is my least common denominator. So this is what I'm going to multiply both sides of the equation by. 3, x minus 3. Same thing over here, 3, x minus 3. Alright, so if we take a look at the first term here, x over x minus 3, the x minus 3's are going to cancel. So all I'm multiplying is the 3 with the x, and 3 times x would give me a 3x. If I move on to the next term, it's the 3's that are going to cancel out this time. So what I'm multiplying is 1 times the x minus 3. And if I multiply 1 times the x minus 3, I simply get an x minus 3. When I go to the right side of the equation, notice there is no denominator. All I have is a 1. So there's nothing that cancels out. I'm simply going to multiply all three of these together. So 1 times 3 is 3. 3 times an x minus 3. 3 times x is a 3x. And 3 times a negative 3 is a negative 9. So here's the equation that I'm working with. I need to solve this equation for x. So the first thing I'm going to do is combine some like terms. 3x plus this x gives me a 4x. Now I'm going to go ahead and get all the x's on the left side. So I'm going to subtract the 3 x's that are on the right. So 4 x's minus 3 x's would give me a 1x. So at this point I've got x minus 3 is equal to a negative 9. Now what I'm going to do is add 3. And a negative 9 plus 3 would result in a negative 6. Therefore my solution is negative 6. However, we need to make sure that that negative 6 is not one of our restrictions. Remember, earlier we said that the restriction we had was x could not be a 3, which is not going to be a problem here because x is equal to a negative 6. Therefore, my solution to this equation is x equals negative 6. Alright guys, number 3. 3 over x squared plus 5x plus 6. We're going to add that with x minus 1 over x plus 2, and that's equal to 7 over x plus 3. What we need to do first is find the restrictions, but before I find the restrictions, I'm going to take this denominator here, and I'm going to put it in its factored form. So the factors of x squared plus 5x plus 6, we're looking for factors of 6 that are going to also add up to 5. In this case, that would be a 3 and 2. 3 times 2 is 6. 3 plus 2 is 5. So what I'm going to do is write that denominator in its factored form. So I'm going to replace that with x plus 3 and x plus 2. That'll just make things a little easier as far as finding the least common denominator and also when we start doing some multiplication. So you'll notice that some denominators they share in common. Well, before we do the least common denominator, let's go ahead and find those restrictions. There's two restrictions in this case. One of the restrictions is x cannot be a negative 2. And the other restriction we're going to have is that x cannot be a negative 3. Again, if I replace x with a negative 2, that would result in a 0 in this denominator. If I had x equal to a negative 3, that would result in a 0 in this denominator. So again, we don't want a negative 2 or a negative 3. These are restrictions. Now what we're going to do is find that least common denominator. Notice they have an x plus 2 in common. That's part of the least common denominator. But they also have x plus 3 in common. So that's also going to be part of our least common denominator. So these two factors make up our least common denominator. That's what we're going to be multiplying both sides by. So this side is x plus 2 times x plus 3. And then we'll do the same thing over here. X plus 3, x plus 2. So on this first fraction, you'll notice that both the x plus 3 and the x plus 2 are going to cancel, leaving us simply with a 3. On the other side, it's the x plus 2 that cancels. So what I need to do is multiply an x plus 3 times an x minus 1. And that's going to require a little bit of FOIL or distributive property. But when I multiply those two together, I should end up with an x squared plus 2x minus 3. Remember guys, that requires a little more work that I'm not showing. That's that FOIL or distributive property. Over on the other side, x plus 3 is going to cancel. So I need to multiply 7 times the x plus 2, which is going to give me a 7x plus 14. So you'll notice that I'm dealing with a quadratic here, and I want to solve this quadratic. And in order to solve this quadratic, I'm going to need to get this thing equal to 0 first. So I'm going to go ahead and start simplifying here. You'll notice that 3 minus 3 is 0. Those cancel. I'm trying to get this equal to 0. So what I'm going to do next is go ahead and subtract 7x's from the 2x. So 2x minus 7x would be a negative 5x. Bring that 14 over by subtracting it. And now I've got the quadratic x squared minus 5x minus 14. Alright, now what I need to do is go ahead and solve for x, and I can use the graphing method. I think I'm going to go ahead and use the factoring method to solve this quadratic. I want to be looking for factors of x squared minus 5x minus 14. What I need are factors of negative 14 that are also going to add up to a negative 5. And in this case, those are going to be a negative 7 and a positive 2. Because negative 7 times 2 gives me a negative 14. And a negative 7 plus 2 adds up to the negative 5. Now that I have the factors, we're going to set each one of those factors equal to 0. And we're going to solve each of these equations. So if I solve the first one, I get x equals to 7. And if I solve this one over here, we get x equals to a negative 2. However, we do have a slight problem. Remember, we had a restriction, and one of those restrictions was that x could not be a negative 2. Therefore, can't include this as part of my answer. The only solution I have to this equation is x equals 7. Negative 2 is what we call an extraneous solution. It's not going to work for us. So again, x equals 7 would be the solution to this equation.